I'm going to be using the example from our experiment 2, Principles of Graphing. The exact example I'm using from is on page 29, so this would be part C of the lab. Even though I'm going to go through all of this with you, you still have to recreate this on your own in order to submit it. One of the important things I want to show everyone is some proper formatting. So in the instructions and in the notes for this lab, I tell you you need to have proper titles for things and that kind of stuff. So I wanted to show you what those looked like. So I've gone ahead and already typed in some of the basic information. So on page 29, this is the information that was already provided to you. Oops, and for some reason Apple News wants to start up right now. That's cool. We don't really need that. Sorry about that. So the first thing you want to do, right, I tell you in the notes for this experiment that you're going to need to show your data tables as well. And so this is a nice way to kind of highlight and organize. This is the data for part C for experiment 2 graphing. So you could do it for part A, part B as well. Then you're going to want to go through and make sure that you have titles for each of your data columns. And in those titles it should be what it is as well as the units it is in. I'll show you when I start making more of these columns how we got lines and bolded stuff and all that kind of good stuff. Please keep in mind when you do something in Excel, the numbers that you're going to use in your graph can't have letters in them. You can't put 190.0C or 0.252 1 over ms. You can't do that because the computer won't know what those letters mean. The computer can only use numbers. So that's why we have to have a column at a row at the top describing what is in that column. So here I have the temperatures that were given to me in degrees Celsius, and I have my rate constant, which if you look in your manual is ms to the -1, right? Meter seconds to the -1. That's the same as saying 1 over meter seconds. It's just easier in Excel to not have to deal with superscripts, so this is just another way to write that. You'll notice that I kept, I made the rate, which is a lowercase k, that's the unit for rate, I highlighted it red. That's because in this particular lab, we're also going to be using the temperature Kelvin, which is also a K, but it's an uppercase K. And I'll mark that in blue. And that's just so that we kind of keep track and can bookkeep and not mix up our Ks and that kind of stuff as we move through the lab. So as we follow the instructions that are on page 29, it says the first of the 3 graphs that we're going to make is K, as in rate, as a function of temperature in Kelvin. So first we're going to have to take our Kelvin, our temperature and convert it to Kelvin. So I'm going to make myself a new column here and I'm going to call this temp, and then parentheses I'm going to put Kelvin, and Kelvin is a capital K. So it looks like that. So you can come up and, like I said, I'm going to denote Kelvin in blue. This is just for bookkeeping purposes of not screwing up my rates and my temperatures. So you can highlight it, you can make it bold if you want. And now I'm going to show you the first equation that you can do as you're doing these calculations. So if you have decided to draft your graphs on the computer, you will have to show your data table, which will be all your calculations. If you're doing these manually, you'll have to show me your actual physical written calculations. Now, it may seem unfair to someone who says that, well, the computer's doing all the work and I'm doing it by hand. Yes, there are different advantages and different disadvantages to doing your work via the computer versus doing it by hand. You have the option and the right to do whichever you want. However, there is quite a bit of work that still needs to go into massaging the data, even when the computer is actually doing the math for you. So the first thing we're going to do is convert from Celsius to Kelvin. And so what we're going to do is we're going to highlight this first column here, and we're going to hit equals. And then I'm going to click on this, and you'll see A4. That refers to A4, this box. And then I'm going to say plus 273.15. That's the conversion to go from Celsius to Kelvin. When I hit enter, the number is generated for me. What I can then do is highlight that box, and you will see this little green square down here. You will click on it and drag it the rest of the way down, and you will see that it will apply the same equation. This is A4 plus 273.15. This is A5, right, this guy, A6, so on and so forth. Okay, so the first thing we need to do is talk about sig figs. Excel does not understand sig figs. You are going to have to manually go in and manipulate your data for each box, for each square. Okay, so again, this is where I was talking about advantages versus disadvantages for using a computer versus hand-drawn. So we had, let's go up to our first one, 190.0. When we're doing addition and subtraction, we know we go by a number of decimal places. So this goes to the 10th place. So this one was in the 10th place. This is in the 100th place. So our answer can only go to the 10th place. Does this make sense? Make sure that you are comfortable with that before we move on. So in that case, all of these, as we look, right, these all go to the 10th place. So our answers here all can only go to the 10th place. So I'm going to highlight this entire block, and I'm going to right click. Oops, sorry. I'm going to highlight this entire block. I'm going to, I won't let me do it. Am I in function? Okay. And because my mouse isn't working. There we go. Okay, once you right click on it, sorry about that, you're going to go to Format Cells. And up here, there's a lot of different fun features we can do with it. We're going to go to Number, and we're going to tell it that we only want to go one decimal place out. This is how you will manipulate your sig figs in Excel. You press OK, and now we can see that it has rounded and done all that great stuff. Here are our temperatures now in the proper number of sig figs that we have for Kelvin. So I'm going to finish this column off. I'm going to highlight it. I'm going to come up here. This is kind of just like all the pretty things you can do with them. I'm going to add borders all the way around. So then that column is done. So now I can go back and look at page 29. It says K, the rate, as a function of temperature in Kelvin. So hopefully you've read through your manual already, and when you see K as a function of temperature, you know who should be on the X and who should be on the Y. In this case, our temperature in Kelvin will be on the X and our rate will be on the Y. So we're going to make our first graph. So just click on a cell that isn't something that has any information in it. So just click a box that has nothing in it. We're going to go to Insert. Again, you may have a slightly different version of Excel. Everything I'm saying, the names of all these different things is the same. They might be in a different location. You'll have to just kind of look them up for your version of Excel. If you're using Google Sheets or any other open source graphing software, you're going to have to find out where these equivalents are for you. So here are the different types of graphs we can make. Some students will screw these two up. We want an XY scatter graph, okay? We want a scatter graph. Don't add lines, okay? We just want the points. So an XY scatter graph. And then it will generate something that looks like this. And you're like, oh man, what do I do with this? In this version of Excel, it allows me to select the data. Sometimes you have to right click and then go in to select the data. So I'm going to select the data. Either way, you'll come to this select data source type window. If you don't have a series here, you have to add a series first. As we get going through our rest of our semester, the series allow you to put multiple lines on the same graph. For this lab, you will have one line per graph. However, as we move forward, you may need to put 2, 3, 4 lines. So you would add more and more series, and this would be 1 line, 2 lines, 3 lines, so on and so forth. But we only need one series for this. So I'm going to go ahead and name this as rate K, I'm going to put the units 1 over ms as a function of temp, and I'm going to put the units for this as well. So this already will generate my title. My x values. The easiest way to do this is to hit this little square over here, and then you can go through and highlight what you want to treat as your x values. Again, don't use the words. The computer doesn't know what to do with the words. Only highlight the numbers. Once they're highlighted, click the little box again, and the computer will go through and know what to do with that. We're going to do the same thing for our y values, which are the rates. We go like that, we highlight it, click the box again. All right, so now we have a name for our chart. We have our x values, our y values. Press OK, and it will generate the graph for you. We're not quite done with our graph just yet. We still have information that we need to deal with. As you've read through the lab, we know that linear relationships have an important, or a linear line denotes a special kind of relationship between the data that's represented in the graph. So hopefully you are seeing that this is not a linear line, right? This is curved. If you think this is a linear line, please come talk to me. This is not linear. This is a curved line. You will see an example of what linear looks like in a little bit. The other important aspects of the chart that we need to add first. We need to add chart elements. So we already have a chart title. That's already in there because we put it in when we made our graph. But the axes need titles as well. Again, depending on your version of Excel, they might be in different places, but you can still add axes to your graph. So we're going to go through and we're going to call this rate, and we're going to say rate K, little k, and then we're going to put the units as 1 over ms, and please make that a little s. All right, and then we're going to come down here, and this is going to be temperature, and this is in Kelvin, so big K, like so. Now, Excel will usually do a very good job of trying to fill the graph as best it can, like fill the space of the graph. If for some reason your graph doesn't start till here, but you're all the way out here, you can double click on the axes and you can start manipulating them. So if you want the minimum to start at 0, or you want it to, you know, kind of cut it off a little bit more so it fills out the space of the graph a little better, you can. But typically Excel will do a pretty darn good job of filling that out for you. As again we move throughout the semester, there will be times where we have to manipulate the data and force it to go through 0 and things like that, where we'll have to change axes. Alright, so there's nothing more to do with this graph. We've determined this is not linear, so we're going to move on from here. Step 2 on page 29 says we're going to take the reciprocal of K, 1 over K, as a function of temperature in Kelvin. So we're going to make a new category in our data table. We're going to call this 1 over K, as in little k. And now what I'm going to do is I'm going to go up here, and again I'm going to make sure I keep this red just so that I'm not confusing my k's. If you're not someone who would confuse little k and big K in a situation like this, you don't have to do this. I'm just showing you this is what I do to kind of keep everything where I know it should be. So one thing I want to bring up, obviously when I wrote out reciprocal 1 over K, oop, I forgot my units. Alright, so if the units of K were 1 over ms, the reciprocal of that would have the units of just ms. So as we can see, this is much longer than these other ones, and it doesn't really fit on in the width of the column that we have. So what you can do is you can go up to the top of the column, and you can see as I put my cursor over, do you see how I get this like cursor with this double arrow with this line thing? Once you get that, stop and just double click. It will automatically adjust the width of the column to fit the words that you have in there. So that's pretty slick. Alright, so now we're going to go through and we're going to take the reciprocal of our K. So we're going to do our next equation. So we're going to hit equals, And I'm going to do 1 divided by, here's my K, so B4, and then I press enter. All right, I'm going to highlight, drag down. There are all my reciprocal rates. However, we know we have to go through and adjust for sig figs. So the rule for sig figs in multiplication and division is least number of significant digits. The 1 is just representing a reciprocal, so that would be an exact number. So we're basing it off of these. And so here I see 3 sig figs, 3 sig figs, 4, 4, 4, 4. So I'm actually going to have to manipulate a couple of these. So the best way to do this is by going back through and doing how many decimal places you want it to be. So for 3 sig figs and 3 sig figs here, in both of these columns, or excuse me, rows, the number is only going to come out 2 decimal places. So I'm going to highlight both of these, and I'm going to go to Format Cell, Number. I'm going to tell it it's already there, but I only want it to go to 2 decimal places. Click OK. Now I have 3 sig figs represented for each of these numbers. For the rest of these, this one, this one, this one, and this one, I have 4 sig figs. So these are all going to come out, or these 2 at least, let's start here. These 2 will come out 4 decimal places. So again, we're going to right click, Format Cell, Number, and we're going to go out 4 decimal places for this one. All right, now we need 4 sig figs in both of these. However, these have zeros after the decimal place, so those aren't significant. So we still need to go out 1, 2, 3, 4, which would be 5 decimal places overall. So we're going to go through and do that as well. Number. Like I said, there are advantages and disadvantages to doing your work on the computer. All right, so we're going to go through and double check that our reciprocals make sense. The reciprocal rate of 0.252, 3 sig figs, 3 sig figs. 3 sig figs here, 3 sig figs here. 4 sig figs, 4 sig figs, 4, 4. And then the last one, these should be 4, but remember that these zeros are leading zeros and not significant, so overall 4 sig figs. All right, so now I'm going to go through, highlight this, and add the box so that I know that column is done. All right, so number 2 on page 29 says the reciprocal of K as a function of temperature in Kelvin. So we're going to make another new graph. Insert XY scatter graph. There's my box. Going to go to select data. I have to add a series first. Don't forget to add a series. I'm going to make the name of this reciprocal K, which has the units of ms, as a function of temp in Kelvin. All right, so now I'm going to add my x values. So again, we're going to hit that little blue box up there. My x values are my temperature in this case. Again, don't highlight the word, just temperatures. And then we're going to do the same for our y values. This time the y values are going to be this reciprocal. So I'm going to highlight those. You can either press enter or click the button again. Review what you have. Reciprocal of K. Units as a function of temperature in big Kelvin. Okay. Press OK. All right. Here we go. Here is our next graph. Again, hopefully you are recognizing this is not a linear graph either. It's a similar curve going in the opposite direction. Hopefully you see that. So again, this is not our linear relationship, but we still need to graph it. And so the last thing we're going to do is add our chart elements of our axes titles. So we're going to add for the x and the y. You go through. Reciprocal K, ms. If you want to put 1 over K instead of writing out reciprocal K, that is fine. Those both mean the same thing. And then we're going to do temp in Kelvin here. Okay. That's it for this graph. Again, it's fine if you want when you're doing your organization of these, if you want to you know, kind of make them a little smaller. Don't make them so small though that I can't read them. That's not going to work for me. I need to actually be able to read what you had written. Okay, so that takes care of number 2 on page 29. The last graph that we need to do is the log of K as a function of the reciprocal of temperature in Kelvin. So now we need 2 more columns here. We need a reciprocal temperature and the log of K. So let's do our reciprocal temperature first. So I'm going to say reciprocal temp. And so this would be 1 over big K. Now again, remember that for me, just for bookkeeping, I'm going to continue to, oops, that's a different color blue. Continue to try and keep consistency that, you know, my temperatures are going to be blue, my rates are red, just so I know what I'm dealing with. Again, when I did that, I get this real long wide column, so I come up here, I wait for me to have it where when I lay over it, eventually I'll get that. Double click, and you will see it automatically widen. So now we're going to go through, and just like we did the reciprocal for the rate, we're going to take the reciprocal of our temperatures. So we're going to hit equals 1 divided by our first Kelvin temperature. There we go. We can click on it, click on that green box, drag it down, does the rest of them. Now again, we have to go through and fix our sig figs. All of these numbers have 4 significant digits in them. So our answer over here can have 4 significant digits in it. As we can see, there are 2 leading zeros in each one of these. So when we go through, we can do them all at the same time. We're going to highlight all of them. We're going to go down to Format Cells, Number. Because there are 2 leading digits in there, we're going to have to go 6 decimal places, right? So now here, the 0, 0, those aren't significant, but we still have 1, 2, 3, 4 significant digits there. Alright, so that takes care of our reciprocal temperature. We'll box that all up. And lastly, now we have to do the log of K. So here I'm going to write log of little k, like that. And again, for my bookkeeping, I am highlighting and coloring so I know which one I'm dealing with. So there's a couple different ways you could do this. The easiest way to insert a formula, so we're going to hit equals, and then you should see a button that looks similar to this. It's basically just a shortcut to all the different functions of different equations that are in Excel. You'll probably have to hit more functions, and then obviously I've been practicing, so I have my recently used up here. If you've never used this function before, there won't really be any recently used ones. You'll have to scroll down. It's in alphabetical order. So you're going to have to scroll down to the L's. You're going to hit log, and then you'll hit insert function. So when I do that, it goes equals log, and it had these parentheses. Come up to the box here, put your cursor in between them, and click on the box that you want to have the number be logged. So in this case, we want the log of the rate, so I'm going to do the first one. So now it says equals log B4. That's what I want. I'm going to press enter. There we go. I got my first log. I can now drag that down so it does the rest of them, like so. And now we have to go through and take care of the significant digits with this one. So if you forget how we take care of sig figs for logs, please go back and look at page 4 and experiment 1A. That is where we talk about what you do with this. So when we take the log of a number, we took the log of this number. There are 3 significant digits in this number. Therefore, the answer goes out 3 decimal places. Okay? So for the first 2, we have 3 significant figures. So we're going to highlight those, format cells, 3 decimal places. Okay, we look down, 4 sig figs, 4 sig figs, 4 sig figs, 4 sig figs. We're going to go like this. These go out 4 decimal places. So again, right? There's a little bit of bookkeeping that you have to do on your own here that you have to go through and fix. If you do not fix your sig figs, points will come off for those. So then we've now adjusted our sig figs. I'm going to box off the column. You can close this out. All right, so our last graph is going to be the log of the rate as a function of the reciprocal of the temperature in Kelvin. So we click on a box where there's nothing at, insert, XY scatter, select data. This is going to be log of, I'm going to put log rate, like that, just so that we know what we're talking about, as a function of 1 over temperature, and this would be 1 over Kelvin would be the units of that. So I'm just showing you a couple different ways you can write your axes titles. Whatever you're most comfortable with is good for you. Oops, I just made a mistake that I keep telling you not to do. You have to add a series first. So delete that. Oops, there we go. Add a series, series 1. Put our title in there. There we go. Now we're back on track. All right, our X values. In this case will be our reciprocal temperatures. Our Y values will be the log of our rates. Press OK. Oh man, look at that. Hopefully you've recognized that that is a very straight, nice linear line. Definitely when we compare it to the other graphs we have made so far today. We can clearly see that unlike these two where they kind of have a curve to them, this is a nice straight line. So this is the linear one. If you go back to page 29, we can see that after step 3, it starts asking us to identify the straight lines and to do some work with them. So step 4 says determine the slope and the intercept for any straight lines that are obtained. Write the equation for the straight line represented in any linear graphs. Step 4 goes on to say circle the points used to calculate your slope on your graph. That's only if you're drawing it by hand. If you're doing it in Excel, I will be showing you what you need to do. So again, real quick, go through. Last thing we're going to do, add our chart elements. Let's polish that off real quick. And we're going to make sure that we have log of rate. And this would be 1, whoops. This would be 1 over temperature Kelvin over temperature. And this would be 1 over Kelvin for the units. All right, so now I have my title, my units. I can go through now and get my intercepts and my slope and my equation of the line. So in Excel, when you want to find the equation of a line, you're going to right-click on any of the dots that make up your straight line and go to Add Trend Line. You will have some options. You want to make sure you will have a linear trend line. You also, for what you will do for us, is hit Display Equation, and for those of you who are graphing on a computer, you also need to display your R-squared. I'll tell you what both of those mean in a second. When we get to our Beer's Law experiment, if you do not use Excel, you are going to have to find out a different way to set your intercept. So I know Google Sheets has a very long and drawn out way to do it. I'm not really sure how it works, but I do know you can do it, but that will be something you will have to figure out. So once you have those set up, you will see that the computer will generate for you your equation and your R-squared. Now, when you do your equation, please make sure I can actually see it. So it usually generates it very, very tiny. You can make it a little bigger so that we can all actually read it. Please put it somewhere where it's obvious and can be read very easily. So here's my equation. Y equals negative 8,483.4x plus 17.668. R squared. R squared is a value used to say how closely does your line hit all of your data points. The closer this number is to 1, the more linear and straight your line is. So we're at 0.996. We're doing pretty darn good. So this is to kind of help if you are ever doing graphing, you're like, well, maybe this is a linear line. If you go through and add a trend line and look at the r-squared of this would probably be something like a 0.7. This would probably be something even less than that. So you can see that these would not really follow a linear relationship like this does. So we have now satisfied all the things that we need for part 4. And then lastly, use the equation of the straight line to obtained from one of your graphs to find the rate, right, the K, when the temperature is 255.7 degrees Celsius. So for that, you're going to need to use the equation you have. In your manual, in the pre-lab section of this book, on page 25 through 26, we go through how you go through this process. So I'm going to let you folks work on that one on your own. Please understand, if you are drawing your own graph, or if you use slightly different numbers, or you forget something with your sig figs, this is why you're posting your calculations in your data sheets. You might end up with a slightly different equation. That's okay, especially if you're doing the hand-drawn ones. They won't be as precise as obviously what the computer is doing. So that's fine, as long as all the calculations make sense with the numbers you have. You won't get any points off for it. But I just wanted to make sure everyone got an opportunity to go through and see how this works. So again, what you will need to hand in as part of your data is going to be this data table here, as well as these graphs, as well as all the ones from part A and from part B. And that should all be in one PDF. Okay? So there's a couple different ways you can go about that. A lot of students like creating a PowerPoint and just kind of copying all this into PowerPoint on different slides, and then they just go through and save that PowerPoint as a PDF. That's totally fine. If you want to make each of these a page as a PDF, and then this is another page as a PDF, I don't care. But only one PDF file, please. I will only be looking at the first PDF file that you submit. If you submit each of these individually as a PDF file, you will only get credit for the first one, okay? Please submit them as one PDF file. If you have questions on how to do that, let me know. All right, so this will conclude our tutorial on how to use Excel. Again, if you have a general question, I'm happy to help, but if you specifically want to know where something is on your computer, you can Google just as fast, if not faster than I can, and then get back to you, right? So good luck. Let me know if you have questions,